Welcome to our webcast. This is your host, Fred Thomas, Industry Director, Discrete Manufacturing Systems for DELMIA brand of Dassault Systems. Today, we're talking with Dr. Michael Grieve on his recently published white paper titled Digital Twin, Manufacturing Excellence Through Virtual Factory Replication. Dr. Grieve has written and lectured extensively on product lifecycle management and is a frequent keynote speaker at international conferences. Dr. Grieve's works include the seminal work on PLM titled Product Lifecycle Management, Driving the Next Generation of Lean Thinking, and his most recent book titled Virtually Perfect, Driving Innovative and Lean Products Through Product Lifecycle Management. Dr. Grieve consults with a number of leading international manufacturers and government organizations, including NASA. Dr. Grieve is also the co-director of the Center for Lifecycle and Innovation Management at the Florida Institute of Technology and is a research professor in the College of Business and College of Engineering. Dr. Grieve, thank you for joining us today for this webcast. The white paper has some interesting concepts, so let's start with a definition as we dive into this a little deeper. What is the model of the digital twin?
Thank you, Fred. The digital twin model was something that I had developed in the early 2000s, and it was this idea that instead of simply having a physical product like we've always had, we now had the ability to have a virtual product, which was the digital representation of that product that occurred in digital space or computers. And the idea of this model, as I say, was developed in my initial courses back in 2000. It's gone through some changes in terms of terminology. I first called it the information mirroring model, but my colleague at NASA, John Vickers, had coined the phrase a number of years back of this being the digital twin, and I think it captures, in essence, the essence of what we're looking at, is that the physical product that we've always had now has a digital equivalent, its digital twin, that occurs in virtual space. And so the elements of this model have remained the same in that we have the physical space and the products that we've always had there, and they basically represent in atom form, what we have created and manufactured. But in the last 30 to 40 years, but more recently since, in essence, the beginning of the 21st century, we've now had the ability to have this virtual representation, which is a very rich representation of the geometry and behavior of the product in virtual space through modeling and simulation. And so these two things have, in essence, formed the backbone of this model. What allows them to be useful is connecting them two together, where you can see data from the physical space and information from the virtual space moving back from the virtual space to the physical space. But by linking these two together, we can use information so that we don't have to be in physical possession of the product. We can possess the virtual product anywhere in the world and know what the physical product is looking at. And so by linking these two together, and we're going to talk specifically on the manufacturing floor, but allows us to, in essence, have a better understanding of how this product works and how we are manufacturing it and what it looks like without having to be physically next to it.
Great. Digital representations and models, though, have been around for a while. What makes all of this more feasible now?
Well, what makes it more feasible now is simply put, Moore's Law, which in essence means that every 18 months we're doubling in computer capability. But Moore's Law, while referred to the density of transistors on a chip, also refers to overall storage and communications. But this whole idea of the digital twin evolution is our ability now to create rich representations in a computer of the virtual products. In the past, we really had sort of just symbolic representations, in essence, descriptions that could exist in a computer in alphanumeric form. We now have the ability to actually visualize that product. And so we have a dramatic increase in virtual product richness and fidelity. We now have the availability of lightweight models, which means we don't have to have all the data, but we can basically have a physical representation of these models in digital form. And we basically have a corresponding increase in physical product digital data from the manufacturing floor through sensors, smart machines, and things like that, that we can collect more data from the floor than we ever have before. What's still lagging is this connection between the physical and the virtual worlds, and that's what we're proposing needs to be enhanced.
Okay, so if I understood you correctly, manufacturers today, where are they really in relationship to using the digital twins? It sounds like the potential's there, but the execution may not be.
Well, so the current model status is what we really have kind of done is we create the virtual product model, and then we, in essence, we do the work in terms of modeling and simulation, and then we basically stop that and throw that over onto the factory floor where we actually sort of create the product. And so we now have sort of the sequential and independent use of these two models as opposed to integrating them. So we develop these 3D models in the engineering bill of material, and then we look to manufacturing to try to create these products by creating a bill of process and a manufacturing bill of material. And there is oftentimes a big disconnect between those two aspects. Because what we do is we create the product and we throw it over the wall to manufacturing. So we do these very extensive modeling and simulation of not only the product but the manufacturing processes in basically these virtual factories. But when we in essence move to physical manufacturing, we lose that. In fact, what the problem occurs in many organizations is we take those models and we dumb them down into 2D blueprints for the manufacturing floor. So we basically lose a lot of our capabilities.
Okay, so how exactly do you see this working in a live production environment? Is it just a matter of closing the loop?
Well, and I think that captures the essence of it pretty nicely, because we have sort of these two independent spaces, the physical and the virtual space. And as I said, the connection between the two have been lagging. So we really need to in essence, close the loop between the two and really implement those connections that I showed in the digital twin model to begin with. But what we need is what I'm calling a unified repository, which would allow us to basically have that connection occur by, in essence, doing two things. One is when we design the product in our digital tools, to basically tag the areas where we are going to, in essence, have the physical information coming from the factory floor, and basically indicate where those characteristic tags and specifications of such things as not only the measurements, but material densities and the tests that we do on the factory floor to ensure that we're meeting specifications to occur. So we're going to tag those in the virtual model, and then when we get onto the factory floor, we're going to take the manufacturing execution system information, and we're in essence going to match them up with those tags that we need in order to be able to populate the virtual model with what's actually occurring out on the factory floor. And so we're going to move beyond factory simulation, which, as I said, sort of ends when we actually build a physical factory, and go to what I call digital factory replication, which means we're going to, in essence, not see a simulation of what our assumptions were about how the factory was going to operate. We're going to actually see how products are being manufactured on the factory floor, but we're going to replicate that in our digital environment.
Okay, let's talk about manufacturing models and where this could apply. Would it be limited, say, to high-mix, low-volume environments that are more order of one or build-to-order type environments, or could it work in repetitive environments as well?
Well, I would sort of view this as being able to work in both environments. That certainly, if we were looking at making individual components like cars, we can basically sort of look at it being sort of build to order and actually looking at the information as each car was produced and looking at the specifications that each car had. So if we were building, for example, Bentleys or Lamborghinis, we would certainly want to see each individual car. If we were mass producing products, we want to not maybe look at each individual item, but look at trend lines. And so making sure that we're not exceeding our tolerance corridors in terms of how we have tolerances built in on the manufacturing floor. In point of fact, we might want to see the fact that if tolerances were drifting in one direction, that we would modify our production facilities later on to drift tolerances in the other direction so we don't engage in tolerance stacking. And so if you look at the example here, we're looking at a modeling and simulation of a factory that is occurring, but instead of sort of seeing what it is in the ideal situation, we're actually overlaying the simulation with information coming directly from the factory floor, and so we're really looking at a factory replication. It's a window onto the factory floor that doesn't occur today unless I'm overlooking the factory itself, and even then, I have no idea what the actual data is until I see the reams of report. This would allow us to, in essence, look at the factory floor and see what's actually occurring out there, and it wouldn't matter whether it's smaller production or larger production. We could basically use this capability.
So this really isn't something where you could just use additional manufacturing engineers to do this. You really have to leverage technology.
Well, it's not only leverage technology, but it's basically adding into the human factor that I think is really instrumental in doing these kind of capabilities. And so I basically kind of looked at sort of three use cases that are how humans think about using information. And the first one is the idea of conceptualization. So you know, while humans conceptualize from reams of data, it's a tough process, and in essence, you know, I can't really share my conceptualization with you because unless I talk to you about it, but you can't see what I see in my mind's eye about when I'm looking at reams of information from a factory floor. What this allows us to do is to do this conceptualization and have a visualization of the physical and virtual activities that are occur so that both of us have a common understanding of what we're conceptualizing. So rather than looking at data or even charts, we're actually seeing what's happening on a factory floor. The second thing humans do is comparison. So what we always want to do is close the gap between what we projected is going to happen and what is actually happening. And so this will allow us to see what we had projected the specifications of the product to be and compare that to what's actually occurring on the factory floor for individual items or trending along many items. In fact, we could in essence use this to zero in on areas that where problems were occurring or we were seeing a difference between what we had projected to occur and what was actually occurring. And then finally, you know, what humans do well is collaborate in order to solve problems. And so instead of having to, by using the digital twin, instead of having to have people all congregate on the factory floor, and even that's not a very good idea because they can only see one aspect of production, is this allows us to in essence, no matter where you are in the world, to look at what's happening on the factory floor. And so you can simultaneously and instantaneously see what is occurring and being able to in essence, see the conceptualization of it and the comparison and being able to then bring to bear your experts from around the globe in order to be able to look at what's happening and solve problems in a collaborative fashion.
So, putting it all together, realization of the digital twin concept has the potential to be a real game changer for a manufacturer.
There's no question. I mean, I think that, you know, we spent all this money in doing these factory simulations, and they're great, and it shows, you know, we can, in essence, take a lot of cost out of the model by looking at problems that are occurring that we would not have sort of seen without doing the modeling and simulation. But this allows us to, in essence, repurpose those simulations into this idea of replication, and in essence, now see not only one factory, but multiple factories that are in production no matter where you are. And so this is a dramatic advance in the virtual product representation and the physical product digital data. And so this basically is, in essence, the fulfillment of the digital twin model by, in essence, being able to compare and look at both the physical product and the digital product all in one place. And this connection, as I mentioned, between the virtual product and the physical product, has been, and maybe missing is a strong word, but certainly incomplete. And so this would allow us to, in essence, be able to in essence, add this missing piece and look at both the physical representation of the product, which we've always had, but the virtual one in doing this comparison. And so connection drives instantaneous and simultaneous perspectives of manufacturing and will allow us to, in essence, see problems faster as they're occurring and being able to in essence, correct them no matter where we were in the world. And so I would contend that this connection would improve productivity, uniformity of production, and quality by basically being able to in essence, use the digital representations to, in essence, see what was happening on a factory floor and being able to react to that in a much quicker fashion and being able to, in essence, bring more resources to bear on solving these problems. So I think that this would really be an interesting new approach to factory production and really bring to bear some really significant capabilities that we've always used in preparing production, but allow it to continue on to the actual production itself.
That's great. Thank you, Dr. Greaves, for sharing your insight from the white paper with us today. And if you're interested in finding out more about the topic of digital twin, please go to aprizo.com and download the white paper. Thank you.